In math, when we talk about ratios, you are talking about a comparison of two numbers by division. Comparison of two numbers by division. You do this all the time, so it's not really going to be earth-shattering or earthquaking as our drill would be. There are, it's an example. For example, if I asked you for the ratio of boys to girls in 7th grade, okay, there are 3 different ways that you can express that. Okay, the most common and the one that you're going to use pretty much all the time is in fraction form. How many boys are there in 7th grade? 11. How many girls? 14. The ratio of boys to girls is 11 to 14. Now please note, it is incredibly important that you see the order that it's given. The first one given has to go on top. The second one given goes on the bottom of the fraction. You can't mix those up because it would mean completely the opposite from what it is. Boys to girls, 11 to 14. A second way that you can write it is you can actually write it out as 11 to 14, just like we say it. And a third way, sometimes you'll see it like this. There'll be a colon between them, and it's 11 to 14. You see this a little bit more in, I don't know, for some of those tests you might take on achievement tests when you're supposed to do those, what they call analogies. Apples are to oranges as grapes are to whatever it is, or however that thing works. They use these a lot. Apples, oranges, blah, 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 blah. But in math, this, ladies and gentlemen, unless they ask you otherwise, if they ask you for a ratio, you will give it in fraction form. Now, if I asked you of the ratio of girls to boys, that's going to be that fraction, except it's going to be flipped over, and it's going to be 14 to 11. When you're given a ratio and it's improper, you need to leave it as improper. You don't make it a mixed number. You do reduce it if you can. In this case, I can't. Okay? But if you can, you do need to reduce it. But you don't, it doesn't sound really, I mean, if you ask somebody for the ratio of boys, their girls to boys, and they said, well, it's 1 3/11 to whatever, that makes no sense. It's 14 to 11, 14 boys, 14 girls, 11 boys. Another example, you might ask, let's see, what does it say here? A 30-foot tree casts an 18-foot long shadow. A 30-foot tree casts an 18-foot shadow. What's the ratio? What's the ratio of the tree length to its shadow? Noting again that order is important. You are looking for tree length first, shadow second. Tree length is 30, shadow second is 18. It's 30 to 18, but if you can reduce, you need to reduce, what, divide them both by 2? Wait, no, divide them both by 6. And you end up with 5 to 3. For every 5 feet tall the tree is, it's going to cast a 3-foot shadow. And that is your ratio. I don't know if it really gets any higher than that. Let me see. Let's find the hardest one in human history here. I do. Yeah, I don't think it gets any harder, not yet anyway.
But he's good with that?
I'm good with that. I think you can handle that, I think we've done ratio before, haven't we?
Yeah.